Hi, it's me, Dr. Prasad Puthiyillam. As class of superconductivity. In previous class, I explained about the basics of low temperature superconductivity. This class is mainly for Meissner effect. So, what is Meissner effect? Just like the ferromagnetism as well as the atomic spectral lines, the superconductivity phenomena can be explained only with the quantum mechanics, and it can be characterized by Meissner effect. So, what is Meissner effect? It was developed or discovered by W. Meissner as well as R. Rosenfeld in the year 1933. So we can call it as Meissner effect or Meissner-Rosenfeld effect, which is the expulsion of a magnetic field from a superconductor during its transition to the superconducting state when it is cooled below certain temperature. Okay, if you take example of a ordinary material or a conductor which is not a superconductor, the magnetic field will penetrate through the material, whereas if it becomes a superconductor, the magnetic moment, it cannot penetrate through the conductor or the superconductor. We can say it is expelled out. If I draw it schematically, if I represent it schematically, a conductor or a material, ordinary material which is not a supermagnet, a magnet is kept over that, and this material is capable to become a superconductor when it is cooled. So here it is, can see that the magnetic field, it penetrates through the material, whereas when it is cooled to below a critical temperature, uh, it becomes a superconductor. Then just like a magic effect, you can see that the magnet will be deviated or levitated, or it will be moving to a certain height. Because of that, the magnetic field cannot penetrate through the superconductor, or I can say expulsion of magnetic field takes place. So because of that, we call it as magnetic levitation. So the placement and subsequent levitation of a magnet above an already superconducting material which do not demonstrate the Meissner effect, while an initially stationary magnet later being repelled by the superconductor as it is cooled below its critical temperature does. It means that if you keep a magnet which is to above the surface of already a superconductor, then the magnet we cannot place over the superconductor, it will be already lifted up. So such cases, it cannot be treated under Meissner effect. The magnet should be placed well in advance, then the material has to be cooled to a certain below temperature, lower temperature, called as critical temperature. Then only it explains the Meissner effect. So a superconductor with little or no magnetic field within it said to be in the Meissner state. Okay, the material which is showing the Meissner effect, we call it as the having Meissner state, or which is in a Meissner state. The Meissner state breaks down when the applied magnetic field is too strong. So if you increase the magnetic field, if a very strong magnet is introduced or a high magnetic field is applied, then the Meissner effect will not exist. Based on the Meissner effect, a superconductor can be divided into two classes. Those two classes are type 1 as well as type 2, which I explain in the next class. So thank you very much for watching my video, and have a nice day.